And here we go again. Welcome back. I'm super excited to introduce the next session. With us is Kyle Kneitinger from Portland in the US of A. And I'm very excited because Kyle is a artist, woodworker, and software engineer, which is kind of exciting because this is also going to kind of dig into the topic of how to combine the physical world with the digital world. But I don't want to give too much away. Kyle, it's your stage, and everybody else enjoy.
Thank you. So good morning, good afternoon, good night, wherever you are. I'm here to tell you about a project I've been working on for, I think, about the past month, but it's kind of blended together. So it might have been quite a bit longer than that, but early stages, but I'm pretty excited to share it. So first, a little about me. I'm a software engineer. Professionally, I've done Rust, C, and Python, and then artistically, Rust, OpenCAD, and Super Collider for music. I am a proud parent. I'm a woodworker. We'll talk about this project a bit soon. And relevant to this talk, I'm an artist, particularly um, I'll be talking about pen plot art. So here's a few of my most recent pieces. Um, yeah, this is for kind of one of those Inktober type projects. But yeah, a whole pen plotter community. We just had this week of plot party. So here's a couple from there. This one has like some mixed lines, widths. This was a postcard one. This one's really cool, and we'll talk about it later during the demo. Um, yeah, this has some kind of nested insets. Oops, sorry if I'm moving away from the mic. This is a variation on that piece. This was an earlier piece that used a connect. A lot of my early work was connect based. So connect piped into Rust, piped into SVG, but we're getting ahead of it. There's some nice, like crisp, thin lines.
Can I quickly interrupt you? We're not actually seeing your screen that you
Oh,
want to share.
yes, yes, yes.
So,
We can start over. Sorry about that.
yeah, no worries.
Okay.
Sweet, that
Okay,
works.
cool.
Thank you.
Yeah, that would certainly be like, it's pretty vital to this talk. So about me, yeah, software engineer, proud parent, woodworker, and art. So yeah, um, this is like a variation on kind of a ripple of waves. This I kind of call like flowers, but it's thin lines mixed with thicker lines. This was a uh, postcard project. This one is the one that we'll be talking about later during the demo. Yeah, kind of geometric insets with some like Boolean difference. Similar theme, just colored. This was the Connect based one I was just talking about. This is just some crisp lines that I'm really proud of. Same with that. So yeah, an overview of the talk. We're going to talk about pen plotters, SVGs, scalable vector graphics, which is how we communicate with the plotter. Some challenges that come with dealing with that over rasterized formats. We'll talk about my initial work in Rust. We'll talk about a detour that I took over to OpenCAD for a little while. And finally, we'll talk about Nightgraph, my most recent project, which is a graphics API, sketches and macros, UIs, a demo, and then kind of an overview of the features I'd like to see later. So plotters, they're little drawing robots. That's kind of it. They're great. There's a lot of cool benefits to them over like a printer. So you can draw on all types of materials. You can use all type of materials. Um, they're fun to work with, and most importantly to me, like as somebody who works with a lot of digital art, whether it's like music or you know visual art, um, I always kind of am gravitated towards ways that we can like blend, yeah, bring the digital into the physical. And pun plotters are like a great way to do that. Also, they produce like really good time lapse videos. So that's like, you don't get that on a printer. So we'll let that finish. Okay. So SVGs, scalable vector graphics. So again, that's what we use to talk to the plotters. There's kind of two forms to it. We have the stroke, which is like that outer outline. Here we see it in blue. And then the fill, which is what we see in green. So yeah, here's a nested one. So we have the stroke in white on both of these, and then fill in green and blue. So the way we see this, it kind of appears to us that they're stacked over each other, right? We see, um, kind of the green one being obscured by the blue, the left on the right, in case anybody has trouble with colors. This is kind of, or yeah, to backtrack a little bit, pen plotters don't recognize fill at all, right? They only know about strokes. Fill is pretty complex. Like, how do you translate that to a pen of finite width? There are ways, but it doesn't make assumptions. So this is what we'd kind of expect the pen plotter to see. But what the pen plotter actually sees, like if we were to draw that as is we'd get this shape. So on traditional like rasterized graphics, like something with a frame buffer, when you put a shape down and then you put a shape over it, you can kind of forget what's beneath it. And that's great. That's super beneficial at times. Like it saves a lot of math, it saves a lot of programming, but we don't get that benefit here. So we actually have to be like explicit and program those breaks in. And so that's a lot of the complications that my libraries kind of have to solve. And that's what we'll go into a bit. So yeah, some of my initial Rust works didn't really deal with that problem. Like I wasn't ready for that yet. So it's just a lot of shapes being put down. There's not a lot of like intersections or differences or anything. But they're still pretty. And the Connect ones, work just as well with that. So you can still get good results without having to tackle some of like the more difficult problems. So after doing that, COVID hit, and I did a project where I just sent out mail, like free mail, to a bunch of my friends with all these envelopes. It was super fun. It was super exhausting, and I got burnt out on pen plotters for a while. So, what do you do when you get burnt out? You go to a new hobby, and that was woodworking. But all that plotter work had kind of given me the itch of like computer control. So, I got a CNC router and I had this vision for this lamp that I wanted to make. This kind of like fractured but really natural shape, and just seeing something like that in wood sounded really appealing. So I spent, I think, like all of June building this and programming it. I didn't do this in Rust. I ended up doing this in a language called OpenCAD. Oh, before we get to that, this is not done by a computer or a machine at all. This was by hand, and I'm just super proud of that. There's no glue in that. That's just like all friction. So just want a little bit of brag in there. Okay, so that does bring us to the language I used. I didn't use Rust. This was my first time dealing with anything like three-dimensional. I hadn't done any 3D printing. I hadn't done any like CNC work in the past, so I wasn't quite sure. I wanted to embark on some Rust library that maybe didn't exist yet, or I wanted to like get my feet wet in a comfortable way first. And a coworker had recommended OpenSCAD, and I really liked it because it was like programmatic. I didn't have to like do a lot by hand, and I could change a lot. But what was really cool is like it has this beautiful interface that gives us a lot for free. So if we look at this code, hold on one second. Also, yeah, just this is my first talk ever. So thanks for being a great audience and for being patient with a little bit of phrasing. Um, so if we look on the right, we have pretty simple code, and OpenSCAD gives us that. Like it's really easy to create like pretty complex shapes just by blending solids together. But what we're going to focus on is this top part. So all I say is like I'm declaring some variables and I have a little comment for them. And for free, just from doing that, we get this really nice like parameters section where default values are set, but we can also um, change them like on a whim, which when you're prototyping, like is a huge benefit. And it really helps out. So in addition to the 3D work, we also get 2D work. Um, it's not as like supported, but it was really fun to like take that design I had just used and translate it see how that would go onto paper. So even though I had like deviated from plotter work a bit, I got to go right back to it. And so I created a bunch of cool pieces from that. And it was really fun, but there were some quirky intricacies. So one of the things is that OpenSCAD doesn't really have the concept of a line, which when you're using a pen is like a pretty big deal. Um, right? You want to be able to like draw a natural line, but everything is a closed shape in OpenSCAD. And so that makes for some interesting problem solving, right? In order to do like concentric lines, you actually have like these solids. If we look at like that kind of inner triangle in this picture, that's a bunch of like solids, like not single lines. So that was one weird quirk, but then I kind of got past that. So it's not quite ideal for everything I want to do. Um, let's see. Yeah, only closed shapes. It's hard to describe like what I mean by this, but there's two APIs. So there's like this geometric API and there's this like mathematical API in there, and they're kind of incompatible. So you can create these shapes that um, are really great, have these powerful operators like union and difference and intersection, but you can't actually combine them in any way, or query them once they're used. So once we've actually like put something down, we can't ask like what's its area or like what's its uh circumference or like where's its center point. Like we lose all that information. So we have to do like really intense number crunching, which isn't efficient. So it leads to like poor performance in this like exact case. And again, no inspection of values. But it is really nice for some reason or for some like purposes. So again, we have those automatic parameters, that interactivity, and this constructive geometric stuff in Boolean operators that I just talked about. And we'll go into that. And so that's what inspired Nightgraph. So currently on GitHub, and again, it's like super beta. It's only like a month old, but it's at nightinger.com/nightgraph. In the future, it'll be nightgenerator.com, but we're getting there. Thanks for the wonderful comments, folks. I'm doing it. So I want to talk about the components of the library, and it's a whole like cargo workspace. And there's like 5 core features, but they're kind of grouped into 3. So one, we have like Night Graphics, which is the graphics API itself. We have Night Sketch and Night Sketch Derive, which is kind of how I take uh, how I create like a sketchbook and like easy project management. And finally, we have some cool UIs. So Night Graphics, that's like the inspectable modular graphics API. And its a workflow is kind of like you create a shape. So that's great. You get all these shapes that are in your toolbox. You optionally have some operations on them, and then you add them to a canvas. And once they're added to the canvas, they're not like gone forever as though as like a rastered like frame buffer. We can still like ask them about themselves, use them to like dictate where other shapes go. So that's the way I like to think. And I'm really glad to like have that toolbox. And then finally, it can render to like multiple targets. Okay, so for shapes, there's a whole set of them, and a lot of them have like really hand builders. So they'll cover all the features they have without like gigantic constructors. So for a path, you might want to make it from like commands, but you can also make it from points. You can close it to be like a polygon or keep it open to have like a smooth continuous line somewhere. You can do like this smooth function gives you like really nice Bezier interpolation. So complex curves like through a point without having to know a ton of like crazy math or like difficult math. And then I have this pre-compute function, which will pre-compute like certain metadata about the shape. So it'll be its bounding box and its representation as like an SVG stroke. Um, and what that does for us is it gives us on sketches where we're going to be like doing a lot of like intersections and stuff, having that pre-computed will save us a ton of time. But if we're not going to like have our shapes interact at all, we can just skip that step. You can change the stroke and you can build it. So here's a similar one with text. Yeah, it's just a helper function that gets us right back to a path, but yeah, it lets us get text. So these are all the shapes at our disposal. And then, yeah, for our operations. So again, I was really inspired by what I had available in OpenCAD. And here we see a difference operator. So I have these waves in the background, and then text is placed above it, but I called difference on it. Now, if I would have called intersection, kind of all we would have left is the lines where they cross like the letters. So that's cool. Union doesn't really make sense in this example, but picture like the B and Y are closer together and we call union and then they're combined into like one outline. Offset was the one we saw in like that OpenSCAD plotter example where we have like all the nested concentric geometry. That was a really difficult one to do. And that actually led to this one design choice that we'll talk about later. And again, like some of the ideas I have and the way I like to think is I like to ask about shapes, but not just the shapes I created, the shapes that are like the result of other operations. So even on the operations we just looked at, the result of those, I can ask for the area, the perimeter, like what would be the closest point on the shape, what's the centroid, which is like the geometric average of a point, like its center of mass. I can ask like what intersections there are, like or like if a line passes through a shape, like how many intersections does it have and where are they? Um, Whether a shape contains a certain point in its area. Again, the bounding box, and then its points, like as its control points. And of course, we can do like simple transformations like moving it, rotating it, scaling it, and flattening it. So taking a smooth shape and turning it into a segment of lines, which artistically or computationally can be really helpful. And yeah, ultimately, you want to add your shapes to a canvas. So the way I've been using it is like the canvas acts as our page, but it is more powerful than that. You can have sub canvases if you like to do like tiled work. Um, yeah, a lot of cool things there. So that brings us to we have this like API, right? This graphics API. But one thing that I ran into in my early Rust work is that I didn't really know, or I wasn't good at like keeping track of uh, all my work in a way that's like really modular. One, it was just exciting to make new pieces, so I didn't put the time into like creating this whole system. But I wanted something that took almost no effort to like enforce this organization. So I wanted something that would be simple to create a new work and have it in this framework. It takes no time. As soon as I have an idea, I can just sketch it out, have it done, and I don't have to worry about adding it to all these libraries and incorporating in this metadata. So yeah, I want a sketchbook that's ready, like when I want it to be ready. So in this context, what is a sketch? So most simply, I've defined a sketch as just um, a trait that when executed gives you a canvas. So everything ultimately like lands on a canvas. And of course we have errors that it could optionally return, which is helpful to know. But what can we do with this? So we have this like execution context, but it's no good without like something to run it. So this is a bit of a spoiler, but let's take a look at the clap library. So clap is used for command line arg parsing, maybe it's an acronym. And it's really cool how it's used. So this is in the new version of clap that's not quite released yet. You can still use it, but it's not a like stable release, but it's based on the struct crate. So we get these like really nice macros that we can define our command line arguments with. So in this, I had an opinion, or like I have this struct that represents the arguments of my program. So one is the string argument, and we'll see what this program does. And then other is a flag. And why don't we run that? So by just adding those and using these attributes on our shape or on our struct, when we compile it, we for free get like this nice like help and usage info. So I passed it -h, and it tells me my application and the arguments and the different options. So why don't we run it? So we know it takes an opinion, and we'll say decent. So this demonstration's decent, not bad. And we can give it a V flag. So we'll say, oh, this demonstration's very decent. And we'll give it a couple more. Unfathomably decent. So let's see how that worked. So we simply just parsed our arg struct. Clap gives us, through derive attributes, gives us this parse method. And that fills out, from our command lines, the values into here. And so we just kind of look at those, and I think a name changes in order, because that was a very bossity given on what it does. Okay. And then we just print our objects, or like our values. So if you've ever used some languages, arg parsing, this will feel familiar, but I really loved the attribute ways that it operated. Okay, with that done, let's go back to this struct or the sketch, and let's scroll up. So we looked at its main method, right, where we fill it out a canvas. But if we scroll up, I have its parameters, its values. So I tag it with sketch, and automatically it's prepping itself to be used in a similar way. And so each parameter can have some metadata about it. So its name is auto derived from its actual name. Its description is pulled from its doc string. We can set a default value, and we can set a range of valid values. This will feel like super familiar to you if you've used clap. Like some of these are verbatim, copies of it. But for example, range is an addition. That's new. So you might be wondering like why I'm not just using clap, and we'll get to that. But it's also noteworthy that if you're familiar with Rust, like if you've done pretty much any Rust programming, you've hit the derive method, or like derive attributes. So derive clap, derive Serday, derive debug, derive clone. This doesn't have that. And the reason for that is this is called a procedural macro, a proc macro. And that's how all these derive methods would be written anyways. But the derive one is its own type of procedural macro. This one's a little bit extended. It's called an attribute macro, and it doesn't give you. It's less restrictive, but because of that, it's a little bit more difficult to implement. The restrictions on the derive allow you to make like some assumptions and create like a easier to use system, but the reason I had to use this attribute one is because I actually want to emit new derive attributes. And you can't do that in a derive one. So I do want to hit or like emit clap arguments from this, but I couldn't do that in a derive. So the available parameter attributes, we have the default value, the range, which again is not a clap one, that's custom, a name override, a description override, and then ignore. So, well, we don't know what these do yet, so ignore doesn't make sense to you, but later in the talk, when we look at what this actually accomplishes, the ignore attribute would just tell it to skip all that. And so from that, we also have a sketch list, right? I want to assemble all these sketches, but it's a lot of work to, say, uh, and some people might find this like very controversial, but I want to stress that this is like internal to a crate that only I'm using, but it gets rid of a lot. There's a lot of magic happening in this macro that is kind of too much magic, in my opinion. So it declares the module, it uses the module, it creates all these accessors and metadata around it. But again, this is about like having something ready when inspiration strikes. Um, so that leads us to Nightgraph CLI, which I assume you might know where this is going. Let's see. Oh, I know where it is. Okay. So just like with our clap example, I ran it with the -h, and I get this Nightgraph CLI shows all my options, and then this subcommand thing. So the subcommand is all the sketches that we added to that sketch list, and it shows a description of it from the doc string. I can select any of them, and if we go even further, why don't we ask that Blossom subcommand, aka sketch, about itself? And so now we get to see its values. Um, those are all the parameters we have. Um, this will feel really familiar to you if you've used like, any of the cargo tools and the help with it. For example, if you look at like cargo expand, like a macro expander, that's really helpful. And I love so much for that helped me out with this. But, any of those like the help pages of that, it's similar thing, right? Using that sub command pattern. And ultimately we can run it with some arguments if we want. So it will render an SVG. We're not going to look at it, but it'll also print the values it used in JSON. Okay, so that's all cool. But what I'm most proud of is Nightgraph UI. So we're going to take a quick stop at this file called, or like this data structure called param metadata. And now that we've looked at like what the sketches look like, this will make some sense to us. And oops. Okay, so what did we have with each of those parameters? We had a name, a description, a range. And so what that macro is actually doing on the back end is it's generating this param metadata value for each of those and creating a vector of that we can pass to our different applications. Now, Nightgraph CLI didn't need that because Clap does things like beautifully, right? But the way that this is used by this Nightgraph UI that we're about to look at is we create a like kind of a UID for the parameter, and we let the application know its name, a description of it for like nice mouse over text or whatever, a kind, and so that's going to be basically its type or its like family of type. So if it's a U integer, it'll be uint. If it's a regular integer, so there's some loss of precision there. It's not yet very respecting of like what values we actually use, but it does some things behind the scenes to kind of make its best to like prevent any to guard against any like invalid values or whatever. And then we have these the range that we can use optionally, right? That doesn't make sense for certain values, like a Boolean. So what does this all culminate to? So command line arguments are really nice, like command, that's fun. But when I think back, when I was designing this, after I first implemented the collapse solution, I was thinking of OpenCAD and like how much I really enjoyed the work I got to do with that, or like the process, the creative process of tweaking values. And so using the eGUI crate, I created this system that displays my sketches, auto generates the parameters. So I wrote, for this particular sketch, I wrote no controls or no code to add these controls to um, this page. The proc macro handles that for me. So this most recent work, it was done by sprinkling a ton of charcoal powder on a page and then having something scratch it. So I needed something to like chaotically go back and forth for these lines. Like if we look really close, let's see. Um, did I freeze? Okay, going a little slow, but it's really scratchy, and I needed it that way. Um, so let's see. Yeah, so we can see here those scratchy lines, and it was really fun to like be able to play around with that without having to like recompile, without having to like on the command line keep hitting up, changing value, hitting enter, hitting up. So for example, why don't we change uh, where the text is, right? I didn't want to like guess that. So it's nice to like be able to see what it is and just run it. We can change the text size. Um, but I want to show you like how performant this is in Rust and like how that helps us a lot. So if we zoom in here, we see, there's quite a bit of lines, but we haven't really even gotten started yet. So why don't we say that for each of these, I don't know, how about like 500 line segments? Okay, so that's cool. But again, like we're just getting started. So there's 12 of these concentric circles. Why don't we bump that up to, I don't know, 160? So that's cool. It's handling it like a champ. Every time I move a mouse wheel or every time I like change a parameter, it's going to recompile, or not recompile, but rerun this algorithm. And just to like really see like how much this is doing, we can hype up the randomness, which will give us an example of just like how many lines there are. And again, it's just like handling it like a dream. Um, I don't think I could do this with this kind of performance in any other language, but yeah, Rust is doing great at it. With that said, there's things that I don't necessarily do well in Rust. So even though like when written well, this is going to perform like a champ, some of my algorithms aren't quite there yet. But what's helpful is like I know due to like the explicitness of cloning and stuff, I have a feeling of where all of my issues are, and I know where I'll be able to like optimize them in. So yeah, let's see, we covered a little demo. I'm not sure how I'm doing on time, so like I won't go into like demos of other ones, but we have some future features that I want. Um, some are pretty painfully obvious. There's no way to export from the UI. So like if I create this like nice picture, I don't have a way to save it as an SVG there. I have to like copy uh, the values and then do it on the command line. I want to be able to handle more types in the parameters. So right now we have numeric types, Boolean. I want to be able to do text. I want to be able to do like structured types, so structs and enums, and yeah. Um, I want to allow resetting the parameters and saving presets. Again, these are like all pretty obvious, but they just like need a little bit of time to get there. Um, Oh, one cool thing, it'd be great to add like keyframes and animations. So in the UI, be able to like set a frame, change a value, like move forward X amount of seconds or whatever, change another value, run that and have like an interpolated animation that we can render to. That'd be pretty, like, I'm not shooting for performance there of something that's like GPU rendered, but just something to augment some of my work. Currently, like one of the biggest issues, so as this runs natively, like imperfectly in WASM. So this isn't like just a tool that I have to enjoy. Like it'll be really fun to like deploy this and let other people use it. However, excuse me, there's no way for people to write programs. Like right now, that's solely on me. Nobody has that ability. They would just be able to modify what I have. So that's kind of the one like benefit that a interpreted language would have over a compiled one. But I want to overcome that with either a node editor, similar to like Pure Data, or like a ton of video editing tools, or a scripting language in itself. So I've been looking. I have a prototype branch that plays with Gluon. I looked at Mun. That seemed exciting. However, it it doesn't have the ability to do dynamic arrays. So that's kind of limiting for the stuff I want to do. And then finally, like a socket communication to the GUI. So right now, if I actually like change the code of any sketch, I need to recompile, and then the GUI pops out and then pops back in. So it'd be nice to not have to do that and like be able to from the command line like communicate with it, just a daemonized GUI. So some gratitude. The Curbo crate is just an API for lines and curves, and it was a godsend. I had a ton of issues with um, the so I had originally implemented the graphics API like solely on myself. So I had like a nice de Castelnau algorithm, which like turns a Bezier into a series of lines, like makes it discrete so that's renderable. And I needed to look up like intersection of curves, and this led me to this repo. And even though I had like thousands of lines of like graphics API done, I ditched it immediately as I saw this and switched to Curbo, and their work is fantastic. MLK eGUI, so the Nightgraph UI is written solely in that, and it's such a great project, like so well documented, native WASM support, and just awesome project. Of course, Clap. On Instagram, there's Penplot Art. It's this wonderful account run by this person, Michelle, who's just been a really good pillar in the community and brought a lot of folks together. And finally, another Rust programmer, FitzGen, did a talk at RustConf in like 2019 about something very similar to this. And so I watched it back then, and then immediately never, kind of removed it and never watched it again because it was really inspiring. But I wanted to solve all these problems on my own and not like follow his solution. So I'm sure it's a great talk. I've intentionally forgotten so much of it, but it was a huge inspiration. So yeah, thank you. If you want to follow my artwork on Instagram, it's Night Generator. On Twitter, it's technically that. I just haven't uploaded anything. And then me personally is Kneitinger. So that's that. Any questions?
Hello, and thank you so much, first of all. I can't believe this was like your first talk. You should have you should have let us know. It's like we were just like gushing like, wow, Kyle's doing so well. That being said, you ran a little bit over time, so I think we cut the questions to no questions, and
Okay.
maybe you can like check them out in the chat.
Sounds good.
With that being said, I want to thank you again, and then we're like going into break. And this is an important announcement for all the people watching the live stream. We will cut the break short, and we will be back already in 20 minutes, so that we can like hop on the schedule as it was planned originally, at like half past whatever your hour is, wherever you are.
20 minutes from now. So whatever time zone time you're at, 20 minutes from now, just rejoin us, go grab a drink or something to eat, take it a little bit easy. Thanks again for the great talk. Yeah, can't believe it's your first one. That's that's incredible. Yeah, thank you so much for sharing that with us.
Yeah. Also, I think people would appreciate your dot files if you have them publicly somewhere, because I was also like very much appreciating just the setup and looking at the nice stuff. But like that's enough like gushing over random things, I guess. Okay, off to the break. See you in 20 minutes.
See you.
Bye.